2.5 million light-years.
That's the distance to the farthest object you can see with the naked eye. A faint, blurry patch in the night sky, so dim that most people have never even noticed it's there. Ancient civilizations thought it was a cloud. 18th century astronomers believed it was a nebula inside the Milky Way. It wasn't until 1925 that Edwin Hubble proved the truth. That faint smudge is an entire galaxy, around 1 trillion stars. And it's heading straight toward us. Today, we're going there. Welcome aboard the Mission Cosmos spacecraft. What you're about to see is a simulation based on everything science currently knows about Andromeda, with a little imagination filling in the gaps where our knowledge ends. 2.5 million light-years. At the speed of light, the journey would take 2.5 million years. We don't have that kind of time. So let's speed things up. And we're here. Take a look. From a distance, Andromeda appears as the perfect spiral galaxy. 2 sweeping spiral arms wrapping around a brilliant central core. It's easy to forget the scale of what we're looking at. This galaxy stretches about 220,000 light-years across. The Milky Way would fit inside it with room to spare. Let's head in. We're passing through one of Andromeda's spiral arms now. This is where stars are born. Vast clouds of gas and dust collapse under their own gravity, igniting new stars that will shine for billions of years. But these spiral arms aren't permanent structures. They're density waves, regions where matter temporarily piles up as it orbits the galaxy. Stars move into and out of these arms over time, continuing their journey around the galactic center. But we didn't come all this way to see young stars. We came for the monster at the center. We're descending toward the heart of Andromeda. As we get closer, the number of stars around us explodes. What was once darkness sprinkled with distant lights becomes an ocean of stars stretching in every direction. And at the center of that ocean is something that emits no light of its own, yet its presence is impossible to miss. The supermassive black hole at the center of Andromeda. We're now passing through the dense central star cluster. Millions of stars orbiting an invisible point at incredible speeds. And there it is, the black hole. Its mass is estimated to be between 100 and 200 million times the mass of our Sun. For comparison, the Milky Way's central black hole, Sagittarius A star, contains only about 4 million solar masses. Andromeda's monster is at least 25 times more massive. But it's asleep. Unlike the blazing quasars and active galactic nuclei that consume matter and outshine billions of stars, this black hole is relatively quiet. Yes, there's a disk of gas and dust surrounding it. Yes, stars orbit dangerously close. But right now, it's not feeding in any dramatic way. At least, not anymore. Let's climb back out. There's more to see. Andromeda isn't alone. It has companions, smaller galaxies trapped in its gravity. And some of them are slowly being torn apart. Our next destination? Messier 32. M32 is a compact elliptical dwarf galaxy. Small, dense. Roughly 160 million stars packed into a galaxy only 4,000 light-years across. For comparison, the Milky Way spans about 100,000 light-years. M32 is tiny, but the most fascinating thing about M32 isn't what it is, it's what it used to be. Evidence suggests that M32 was once a much larger spiral galaxy, but after falling into Andromeda's gravitational grip, it began to lose itself. Over billions of years, Andromeda stripped away its outer layers, stole its stars, and reshaped its structure. What remains today is the dense core we're looking at now, the surviving heart of a galaxy that was cannibalized. And Andromeda wasn't finished.
Our next stop, Messier 110. M110 is different.
Larger than M32, it contains roughly 2.1 billion stars and stretches about 14,000 light-years across. Like M32, it's an elliptical galaxy, but it's more diffuse, less compact. And it has something M32 doesn't: nebulae. According to astronomical catalogs, M110 contains 21 known nebulae. That's unusual. Elliptical galaxies are typically made up of old stars with very little ongoing star formation. The presence of these nebulae suggests that M110 still contains regions where new stars are being born, or that it acquired this gas relatively recently. From here, looking back, Andromeda dominates the sky, a giant spiral galaxy surrounded by two tiny companions. It's almost ironic. From a distance, M32 and M110 seem insignificant. Yet each one contains billions of stars, billions of possible worlds, billions of stories we'll never know. And in about 4 billion years, all of this will merge with the Milky Way. These galaxies, and our own, will become one. But that's a story for another journey. It's time to head back to Earth. $2.5 million light-years, the longest trip we've ever taken. And yet, on the scale of the universe, Andromeda is our closest giant galactic neighbor. The next time you look up and spot that faint smudge in the constellation of Andromeda, remember what's really hiding there. A trillion stars, a black hole 25 times more massive than our own. Galaxies slowly consuming one another, and a future in which all of it will collide with our cosmic home. The light reaching your eyes tonight left Andromeda 2.5 million years ago. When that journey began, the first humans didn't even exist. And by the time Andromeda finally meets the Milky Way, humanity as we know it will almost certainly be long gone. But for now, we can still look up and see. We'll see you on the next journey.